This training video and accompanying manual are intended for use by persons having electrical and mechanical training and a level of knowledge of these subjects generally considered acceptable in the appliance repair trade. The manufacturer cannot be responsible nor assume any liability for injury or damage of any kind arising from the use of this information. To avoid the possibility of personal injury and/or property damage, it is important that safe servicing practices be observed. Examples of these practices are contained in the service manual. Induction cooking uses high-frequency magnetic energy to heat the cooking utensil when it is placed over the induction coil. The induction fields have no effect on non-magnetic surfaces such as paper, plastic, or non-ferrous metals like aluminum, copper, etc. Induction cooking requires two essential components to operate. The first component is the induction coil or element that is located beneath the cooktop glass. This coil generates the magnetic induction field needed for induction cooking. The second key component is the proper type of cooking utensil or pan. The primary requirement of the pan is that the bottom must be constructed of material that will attract a magnet. If a magnet will not stick to the bottom of the pan, it cannot be used on an induction cooktop. When the proper type of pan is placed over the induction coil, it generates a field of magnetic waves that react with the material in the pan bottom, causing it to heat. Unlike traditional gas or electric cooktops, there is no visible flame or glowing coil. The induction fields cannot be seen. Induction cooking is highly efficient since the energy created by the induction fields is not wasted by heating the glass or surrounding area of the cooktop surface. Due to this increased efficiency, the contents of the pan are heated more quickly than with gas burners or traditional radiant electric and coil elements. With induction cooking, the surrounding surface remains cooler than with traditional cooktops. There are numerous brands and types of cookware available that are acceptable for use on an induction cooktop. The primary requirement of any cookware to be used for induction cooking is that a magnet will stick to the bottom. The size of the magnetic portion of the pan bottom determines the effective cooking diameter of the pan or utensil. The fry pan in the diagram has an overall diameter of 9 inches, but the bottom is only 7 inches in diameter. The effective cooking diameter of this pan is 7 inches. Some pans are constructed entirely of a magnetic metal, while other pans may be made from a non-magnetic metal alloy with an attached bottom plate or encapsulated core of magnetic material. Here we see a fry pan with an overall diameter of 9 inches and a flat bottom of 7 inches. The encapsulated magnetic core has a diameter of only 6 inches, therefore the effective cooking diameter of this pan is 6 inches. Knowing the effective cooking diameter is important when selecting the proper size cooking zone on the cooktop to match the pan that is being used. There are also variations of the shape and thickness of the encapsulated core found in different cookware. In this diagram, we see a fry pan with an encapsulated core that is thick near the center of the pan and thinner near the outside edge of the bottom. These variations will cause different cooking characteristics, but will work with an induction cooktop. For best results with an induction cooktop, the pan bottom should be as flat as possible, with no deep grooves or ridges on the bottom surface. To see if a pan is flat, place a ruler or similar straight edge against the bottom of the pan. If the pan is not flat, there will be a visible space between the pan and the ruler. Pans that are not flat or that have grooves or ridges on the bottom will not be as efficient as smooth, flat-bottomed pans. If the cookware is severely warped or bowed, it may not function on the induction cooktop. There are four basic modes of operation that the control can be in. These are standby, ready, in use, and locked. In standby mode, line voltage is applied. No cooking zones are activated. No displays are illuminated with the exceptions of hot zone indicator or timer countdown in progress. In ready mode, the cooktop main power is turned on and awaiting a function key press. In the in use mode, at least one of the cooking zones is in use. In the locked mode, all displays are off with the exception of the locked LED. No functions are available until the unlock sequence is performed. To turn the cooktop on, the unit must be in the standby mode. Press the power button for 3 seconds. The power on LED above the power button will illuminate. A short beep will sound and the control will be in the ready mode. The cooktop will be ready to accept another key press to activate a zone or the timer. If no keys are pressed within 10 seconds, the control will automatically revert back to the standby mode. To turn off the cooktop, if the unit is in the ready or in use mode, press the power button for 3 seconds. The control will deactivate all cooking zones, turn off all displays, and a short beep will sound. If the control is in the ready mode or the in use mode, a cooking zone may be activated. Each cooking zone control section has a digit display, a down key, an up key, and an on-off key. To turn on a zone, press the zone on-off key for the desired zone. The digit display for that zone will show 0. Press either the zone up key or the zone down key to activate the cook zone. If the up key is pressed and released, the letter P will be displayed in the digit display to indicate power boost. If there is not a proper pan on the selected cooking zone, the letter F will flash in the control display for that zone, and no induction fields will be generated. If a different power level is desired, the up or down keys are used to select an intermediate power level. Pressing and releasing the up or down keys will increase or decrease the power level by 1 step with each key press. A beep will sound with each key press. If the up or down key is pressed and held for 2 seconds, the control will continue to raise or lower the power setting until the key is released or the maximum or minimum power level is reached. When the desired power level is displayed and no further keys are pressed in that cooking zone for 5 seconds, the zone will start heating. If the zone on-off key is pressed, but no up or down keys are pressed for a period of 5 seconds, the control will revert back to the ready mode without activating the zone. If the control was in the ready mode, the zone digit display will be lit with a solid 0. If the control was in the in-use mode, the zone digit display will turn off. To lock out the cooktop controls so that the cooktop cannot be used, turn off all cooking zones and turn off the main control power. Touch and hold the lock keypad for approximately 5 seconds until the indicator light above the keypad comes on. The cooktop is now locked and cannot be used until this sequence is repeated to unlock the controls. The recommended way to use the touchpads on the cooktop is to place your finger in the center of the touchpad as shown. If the finger is not placed on the center of a pad, the cooktop may not respond to the selection made. Lightly contact the pad with the flat part of your entire fingertip. Do not just use the narrow end of your fingertip. The touch control is a capacitive touch system. When the glass keypad is touched, the circuit is completed and the touch control responds to the selection. If the touch control is not properly touching the underside of the glass, the signal strength is much weaker and the control may not respond. Always ensure that the touch boards are properly positioned and mounted. Whenever you are servicing the induction cooktop, be sure to turn off the power supply to the cooktop. Remove the mounting screws that secure the cooktop to the mounting brackets and lift the cooktop out of the countertop. Place the cooktop on a protected work surface. Place a wooden block or other suitable spacer under the bottom of the cooktop to avoid pressure on the flexible conduit strain relief. To remove the glass top and frame, take out the 3 screws in the bottom of the air deflector and 1 at each end. Remove the deflector and place it aside. Remove the remaining screws that secure the cooktop glass and frame to the burner box. Carefully lift the cooktop glass and frame away from the assembly. With the glass top and frame removed, the induction coils, touch controls, and insulation panel are accessible for service. Use care when handling the induction coils and insulation panel to prevent damage. When handling or servicing electronic parts, follow proper procedures to avoid component damage due to static discharge. Unplug the center wire harness connector on the main touch control board. There are 2 identical edge connectors on the board. These are parallel circuits and either connector can be used. There is an additional edge connector located on the main touch control board that is not used. With the center harness disconnected from the main touch control board, the main touch control board and left and right cook zone touch control boards can be lifted off their locator pins and removed from the cooktop assembly. The left and right cooking zone touch control boards are identical. The main touch control board, the cook zone touch control boards, and wire harnesses are all replaced as separate component parts. The cooktop seen here has an aluminum spacer plate below the touch controls that may not be present in later production models. In order to remove the induction coil, unplug the temperature sensor connector plug from the power board. The connector plug is released by squeezing the tab and lifting the plug upward. Using a number 25 Torx screwdriver, loosen the screw terminals on the power board and disconnect the induction coil wires. The wire terminals are forked and can be disconnected without completely removing the screw. To test the coil, use an ohm meter to check for continuity between the 2 forked terminal connectors. The coil should have less than 1 ohm of resistance. Each induction coil assembly has a temperature sensor as part of the assembly. To test the sensor, use an ohm meter to measure the resistance between the 2 wires in the sensor connector plug. The sensor should measure approximately 1000 ohms of resistance at room temperature. The sensor monitors the surface temperature of the cooking zone and relays this information to the controls. If the surface temperature is above 149 degrees Fahrenheit, the hot surface indicator H will be displayed in the cook zone control display when the cook zone is not in use. If the control detects surface temperatures above 464 degrees Fahrenheit, it will turn the cook zone off. This is intended to prevent damage to the cooktop and cooking utensils in the event of an empty pan left on the cooktop or if a pan should boil dry. Whenever this shutdown occurs, the cook zone control may display the minus symbol or have no display. After the surface cools down sufficiently, the cook zone control can be reactivated in the normal manner. Induction coil connections. This diagram shows the difference in the wiring configuration of the left side and right side induction coil. On the left side, The rear induction coil wires connect to the rear set of terminals on the left side power board. On the right side, the rear coil wires connect to the front terminals on the right side power board. If the coils are not connected to the proper terminal set, the cook zones for that side will not operate, and the control will display the flashing F when the zone is turned on. It should be noted that the individual wires from each induction coil have no polarity and can be connected to either of the screw posts on the power board for that specific cook zone. After the touch controls, induction coils, and insulation pad have been removed, take out the 10 screws that secure the coil carrier panel to the plastic housing. When reinstalling these screws, use care not to over-tighten and strip the receptacle in the housing. Lift the panel off and place it aside. With the coil carrier panel removed, the induction power components can be accessed. From this point, either of the induction power generator boards can be removed and replaced, as well as the filter board, cooling fan, heat sink thermal cutout, and connecting wires and cables. To remove and replace the power generator boards, begin by removing the heat sink thermal cutout. Next, remove the 2 metal clips that clamp the heat sinks together. Gently pry the clip off with a small screwdriver. To unplug the flat cable connector on the filter board and the power generator board, use the special cable removal tool. This tool is packaged with each replacement power board and filter board, as well as with the replacement cable. Grip the connector with the tool as shown and pull up to release the connector. Unplug the blue and black wires from the power generator board terminals X1 and X2. When reconnecting these wires, terminal polarity is not important. Remove the 2 Torx screws that mount the board to the outer case. Lift out the induction power generator board. To remove and replace the filter board, it is necessary to disconnect the power cable wires and copper jumpers at the terminal block on the underside of the board. The main housing can be lifted up to gain access to these wires. Remove the Torx screws that secure the wires and jumpers. These screws must be completely removed when replacing the filter board. When reconnecting the power cable wires, ensure that the copper jumpers are connected to terminals 1 and 2 and 4 and 5. When reinstalling the housing, make sure that the air intake slits in the housing are located over the cutout in the panel below. Make sure that the cutout in the insulation board is aligned with the cutout in the bottom panel. Once the power cable wires are disconnected from the filter board, unplug the wires and cables from the filter board to each of the induction generator power boards, main touch control board, heat sink thermal cutout, and the cooling fan. Remember to use the cable removal tool to remove the flat ribbon cable connector. Release the locking tabs on the edge of the board near the cooling fan. The filter board can now be removed from the housing. When reconnecting the wires and cables, make sure that the cables go to the correct induction power board. The polarity of the blue and black wires is not important. Whenever a failure or error code is encountered, the power supply to the unit should be checked before beginning disassembly. Verify proper voltage and orientation of the power supply wiring connections. Turn off the power supply for 30 seconds and reset it to see if this will clear the error or failure before attempting to replace any parts. Refer to the installation instructions to ensure that the unit is properly installed. Verify that the unit is being operated in accordance with the instructions found in the owner's manual. The electronic components in the induction cooktop have built-in error codes to assist in the accurate diagnosis and repair of the unit in the event of failure. The chart on page 23 in the service manual provides a list of the error code numbers as well as the likely cause and suggested corrective action. When an error code is displayed, the letter E will be displayed in the cook zone touch control boards, and the error code number will be displayed in the center touch control timer window. An example of this would be E35, indicating improper low voltage at the power supply. Confirm this by testing the incoming power supply at the power cable connections. These connections can be accessed without removing the cooktop via the cover plate on the underside of the burner box. Additional failure conditions that may not present an error code can be found in the chart on page 24 of the service manual. Follow the steps outlined in the chart to diagnose and repair these failures. An example of this would be if the cook zone control displays the hot surface indicator when the cooktop is cool. The most likely cause for this condition is a failed sensor in the induction coil. Remove the cooktop glass and unplug the sensor connector. Test the sensor for a resistance of approximately 1000 ohms at room temperature. If a significantly higher resistance is measured, the sensor is defective and the induction coil must be replaced. If the resistance is correct, then the power board for that cook zone must be replaced.